Hi friends, in this class I like to cover tree, twig, link and the relation among these three. Okay, so we have already discussed the definitions of tree, link and also twig. So let us see what are those things, and let us see the what are the different properties of a tree. So if tree is there, what is its what are different properties? Those things we will see. And if twig is there, link is there, number of nodes, number of branches, so what is the relation among all these four? So those two things we will discuss in this video. Let us first see what is meant by a tree. So tree means it is an interconnected open set of branches which include all nodes. So definitely tree means it is if a graph has been given to us. A graph has been given to us, definitely it will be a interconnected. That means there should be some loops. Definitely loops should be there. Then only we can call it as graph or network. Okay, it should not be generally, in general it should not be an open circuit. Okay, it's just like a closed path and closed things. Now how can we make a tree? A tree can be made by using a tree can be made by using so a tree can be made by using or by removing some of the branches. So how in which way we need to remove them? We need to remove the some of the branches such that it should be an open circuit, completely open. There should not be any closed loop. Okay, of course we will see the some examples also, then we can come to know what exactly the tree means. Coming to twig means, for example, a graph has been given to us. We have removed some of the branches, and we made a tree. So obviously tree contains some branches and we have removed some branches. So the branches which are having a tree contains are called twig. The branches which we have removed are called link. Okay, simply these are the definitions. So we can go ahead with the properties and the relationships. Yes, first we will see the properties of a tree. Yeah, so let me go back to definition. So it is an interconnected open set of branches which include all nodes. So definitely in properties, what may be the first point? Definitely it includes all the nodes. So obviously properties means it contains all the nodes of the graph. Nodes of a graph. Next point. So obviously we know that it is an interconnected open set of branches. That means there will not be any closed path in it. There will be no closed path in the tree. So there should not be any closed path. Any closed path. Yes. So how many trees we can frame? Okay. There can be different trees. There can be many possible number of possible number of trees, depending on number of nodes and branches. Nodes and branches. So one more property is, if there are capital N nodes in a graph, the tree will have n minus 1 branches. Then the tree will have n minus 1 branches. So that's all. So these are the properties of a tree. So let me go ahead with the relationship between twigs and links, and let me end up with a beautiful example, so covering all these points. Okay, so don't worry about that. So let's move forward and let's see the relationship between twigs and links. Of course, the relationship between twig and links, and also between number of nodes and number of branches also. Yes. So a graph has been given to us, and let capital N is equal to number of nodes and capital B is equal to total number of branches. Total number of branches in a graph. Total number of branches in a graph. Now we have framed the tree. That means some branches have been removed, and the branches which a tree contains is called, obviously, twigs. So number of twigs, let me write it as capital T, which is equal to capital N minus 1, which was already discussed, and number of twigs capital N minus 1, and number of links capital L is equal to, this is number of twigs and this is the number of links. Yeah. So number of links means the removed branches from a graph to make a tree. So how this can be done? So this means capital L is equal to total number of branches, capital B, and we have removed some branches, and which are called, we need to subtract twigs. So we know that a graph has capital B number of total branches, capital B, and we have to remove some branches and we have to keep some branches for tree. So the branches which are keeping for tree are called twigs, and the removed branches are called links. Now tell me, what are the number of links? So obviously number of links capital L is equal to capital B minus number of twigs, that is capital B minus of n minus 1, where n is the number of nodes. Simple concept. Okay, let's quickly solve one problem so that we can have a very good idea on it. Yeah. Okay, let us solve the problem in the next video. So by keeping all these information, so no problem for that. And so thank you so much for your careful listening. And this is the information regarding tree, twigs, and links. So this is very important to go ahead with the tie sets and cut sets also. So let us see how beautifully we can cover all these topics. And in the next video, I will give the example by noting all these values and all these points. Thank you so much for your careful listening, and please like this video, share this video, and please utilize this video for your upcoming knowledge gain. Okay, thank you so much. And don't forget to subscribe to our YouTube channel, and please press the bell button so that you will get the notifications whenever I upload any video. Thank you so much.